Well, you mentioned data engineering. So I guess I wanted to know what the difference is. Like, what's the difference between like data science and data engineering? Is it the same thing? Is it a different thing? Like, what's the deal?
So if I were to describe the difference between data science and data engineering in like a single line, I would say data science is all the mathy stuff where the math happens, and data engineering is taking the math and making it work on in a distributed cluster of nodes. Right?
Okay. So like weaponizing, weaponizing science.
I actually like to use that metaphor very much. Right?
Okay.
I like to describe data science as being the payload, and data engineering being the missile. Right?
Okay.
So it takes the payload to its destination.
Makes a lot of sense.
So there's a lot of that work happens, right? But as is the case with everything else, it takes away all the nuances out of the distinction,
right?
Out of the definitions, right?
Okay.
But if you thought about it a little, right? I mean, it's also the type of skills that are required for each of these things. Right?
Sure.
So data science, since it fundamentally entails like creating these models and stuff based on that try to predict a certain phenomena. So it involves a healthy mix of like business domain knowledge, and then it also involves a lot of math, right? Because you're trying to create these mathematical models that try and predict stuff.
Right.
Engineering, like to my mind, has always like it's obviously based has mathematical base, and different kind of math is involved.
Yeah, I think it's generous when we call it engineering, right? Like we're kind of kidding ourselves a little bit.
Like to my mind, engineering has always been about like making things work, right?
Yeah.
Like good enough, right? Basically better than what we currently have. It doesn't need to be perfect. It doesn't need to be pure. It doesn't need to be it usually is not pure. It usually is not perfect. But
you're making some compromises. You're cheating on the algorithm a little bit or something.
So I feel like there's certain amount of that attitude that creeps into this whole distinction as well, right?
Okay.
So you have these engineers who like, if it works faster, if it works better than what we currently have, we are set.
Yeah.
Whereas you have like these data scientists coming in from a very mathematical background, where they're like, this needs to be a little purer.
So is that hard? Like, is it hard having those conversations with so these data scientists are kind of living in this platonic world, right? And they're like, oh, there's this pure mathematical function, and this is the way it has to be. And then you're like, well, actually, that will take 2 years to compute, and this is supposed to be real time. So do you have to have a lot of those kind of awkward conversations, or do they tend to be open to tweaking?
I think it also depends on how long they've been doing data science in the real world for, right? Because if they've been like doing data science for real business and stuff, right, they probably get this fact very soon that you need to have something that works better than what they currently have.
Right.
It doesn't need to be perfect, it doesn't need to be scientific, but it needs to work better than what they currently have.
Yeah.
And like the longer you do that, right, the more open you are to this idea of being a little bit more, I would say, experimentative, where you say, I think this approach might be better, so let's test this approach. If it works, let's push that out. That's how the user sounds.
So that's interesting, because I never really thought, I know like, so there's a lot of times I hear like UI people and UX people talking about kind of doing cheap experiments and iterating fast feedback. Is this same kind of stuff happening?
I think it's just as relevant to the data science world of things, right?
Interesting.
Because this is something that I gleaned from a conversation I had with one of our colleagues from Australia who worked in something similar, and they were speaking about how they had a certain model and they had like pushed this model out to test with real people because the mechanisms that they had to test the model were would only go so far to validate it. So then they had to do some cohort analysis where they identified a set of users and
also like full on like A/B multivariate testing and all that stuff.
Exactly, testing of that sort, right?
Interesting.
So I feel like there's a whole lot of like practice of that sort where data science would learn from engineering, right?
Yeah.
Because we're accustomed like thinking in terms of testing stuff because we don't necessarily have mathematical proofs for what we do.
We're just hacking away and we don't really know what we're doing.
We just like some mechanism to validate what we're doing.
Yeah.
So something of that sort of.
So if I wanted to be a data engineer, so I fantasized about being a data scientist, and then I realized I'm crap at math. Do you think I could get away with being a data engineer? Like if I know do I need to teach myself R? Do I need to pretend to be a pirate and
no.
Get it? R?
So actually, I probably misspoke a little when I said earlier that there isn't enough math in engineering. There is a lot of math in engineering, but the type of math
I can't be a data engineer.
A little different. Right, but then I haven't come across anybody who's like really crap at math. I mean, you may not necessarily not necessarily like a certain kind of math, but there's other kinds of math that you might like.
I think so. So like stats is the stuff. So stats, I've never like it's like the opposite of intuitive to me. Like it's like totally counterintuitive. So I always felt like I can't do all this data sciencey stuff because I don't understand what a chi-squared whatever thing is. But could I still do?
You still could be a very good data engineer. Right? Because I think, like, to my mind, the primary requirements for somebody to be a good data engineer is that the person should understand distributed computing.
Okay.
At least to the extent saying that if
I
you're
can
trying to
do
build
that.
like a certain task, that needs to be broken down into like 10 different bits, runs on 10 different machines, and then the values, the outcome or output is all like brought together, and you have like a single response. Now, to be able to like think through this process and knowing that some of these tasks are going to fail, some of these machines not going to work.
Yeah. See, that's the stuff that I find really interesting as well. So that'd be fun.
That's exactly what data engineering is about, right? That to my mind, is what data engineering and the distributed computing stuff is about.
Gotcha. Where the rubber hits the road.
Yeah, where the rubber hits
the road.
Exactly.